to everyone, to respected speakers. So, welcome to FCAP Industrial Talk 2023 on application of IR 4.0 wastewater treatment. Textile wastewater treatment Batu Pahat Johor, organized between Eco Solution Services Sdn Bhd and UTHM. So, Mr. Lim, this is first time we met, through
Yep,
online. So,
through online.
my name is Shailene. So I'm the one of the Sustainable Campus Office, UTHM, as well as the FCAP staff. And I will be serving all of you as a moderator today. So today everyone will be hearing a sharing session from our honorable speaker, Mr. Lim Kai Keng. But first of all, I would like to give a brief introduction on our speaker. So Mr. Lim Kai Keng had his Bachelor Engineering degree in Chemical and Process Engineering in 2000, correct? At Newcastle upon time UK. So currently he is a managing director of the Eco Solution Services Sdn Bhd and had more than 23 years of industrial water and wastewater operate and management experiences. So you have a lot of experience related to wastewater. So thank you for joining us and putting your time to share your experience with all the students. So, but before we get started, I wanted to take a few minutes of all everybody times. The verbal Q&A session will be carried out at the end of the session. However, if the audience have any question, you can always ask in the chat box. I will read through at the end of the session. And then before that, for the student, please make sure you fill in the attendance form. So we use the attendance form as a proof of your attendance for today. Lastly, please switch on your camera. I hope everybody can switch on the camera. We have our photo session before the talk since everybody is looking fresh. Yeah. Okay. Everybody, could you please switch on your camera?
Yep.
All right. Mr. Lim, could you please unshare the slide so that I get all the full screen of the participant?
Right. I unshare my screen.
Thank you.
Just wait for a moment. I stop sharing.
All right. Okay. Everybody get ready. 1, 2, 3. Okay. Another one. Okay. Another one. 1, 2, 3. Right. Okay. Another one. Okay. Last one. 1, 2, 3. Okay. Thumbs up, maybe. Thumbs up. Right. Okay. 1, 2, 3. Okay. Thank you. I think.
Right.
Okay. That's all. Mr. Lee, you can share your slide again. Slide back.
Share my slide again. So everyone can see the slide?
Yeah. Yes, Mr. Lim.
Okay. So I really thanks that I was being invited by the university for this sharing session. So as I think just now Shereen mentioned that we have I actually started with this water treatment line 23 years ago as sales and service personnel, and we basically build wastewater plant, operate the wastewater plant, and we help customer to monitor the wastewater plant in the sense that we put in this operator and competent person to help customer to operate the plant. So throughout these 23 years, I think we realized that in industry, there's a lot of difficulty, especially when we talk about people and we talk about lack of manpower and monitoring. So we actually developed this type of monitoring, or what we call Industrial 4.0, about a few years ago, and we are trying to implement this in some of the industry. I think so far we have 2 customers already started this monitoring. but I think we can't get all the industrial 4.0 characteristic being implemented in each one of them. I think later I will share how we implement all this into the system. Okay, so as everyone know that Industrial 4.0 started with Industrial 1.0. So 1.0 is started in England. We all know that when the English guy invented the steam engine, and it started the Industrial 4 1.0, whereby mass production and have been started. While 2.0 is basically the revolution of electricity, and it started, and the mass production of product started. Now, 3.0, Industrial 3.0, basically is about internet, it's about computer. So the new era has come whereby Industrial 4.0, we are actually focusing on Internet of Things and the improvement of the industry. Okay, so if you look at this chart, Industrial 4.0, basically it covers some of the characteristics. First of all is you must have the related sensor monitoring, industrial IoT as industrial application, quality that we want to monitor, and the internet security. For the automation part, I think some is also very important when you have all this data and what is the purpose you want to monitor. So if you look at this sharing about wastewater treatment, so I think this is a very typical wastewater treatment plant in a very grand way. So if you look at it for textile industry, first of all is the first process is what we call a cooling tower, as you can see here. Because the wastewater coming out from textile industry is quite hot. It estimated is about 60 degrees Celsius when it first discharged from the wastewater treatment. So next, we will have this clarification process. For the clarification process, or some of us call it a physical chemical treatment. Physical chemical treatment is whereby we adjust the pH, we introduce coagulation and flocculant, so that all this colloidal could be separate from liquid, what we call partial dissolve to a solid form, and we allow this solid and liquid being separate from the system. And clarifier mean that is an instrument, or what we call a unit operation, to allow the liquid and solid being separated. Next, we'll go to the aeration pond. Aeration pond is what we're trying to dissolve, or what we want the biological process, or what also is known as this activated sludge. Activated sludge, it consists of biological bacteria, and it will consume soluble COD and BOD. So for students which have knowledge on COD and BOD, I think you should know what is COD and BOD, because this is the parameter whereby we measure how much pollutant inside wastewater using a standard whereby how much air is needed to back to the original stage of the water. Say we know that pure water is about 0. So if you have highly polluted water, how we measure the water is the pollution level of the water is by calculate how much oxygen or the oxidation is needed for it to back to the original or pure water stage. So this is how to do it. So aeration consists of biological. So it will be the COD and BOD will be consumed by this activated sludge or bacterial. So the contact oxidation pond is basically more on anox bacteria, which is a stage whereby aeration and anaerobic anaerobic process occur in this stage. Next, we will have this secondary clarifier. Secondary clarifier is the separation of what we call the activated sludge, so that clear water can be separate from those bacteria. And by then, the wastewater will be clean and ready to discharge. Is there any questions so far? So if it's not, we will go to the real scenario of wastewater. I think based on this picture, student can see it's very nice, right? So this is what happened in the actual wastewater plant. If you look at those color, is an old building, and a lot of them is not what we are expecting. Because real life, we are talking about economy, and we have to make sure that what we call the factory can make profit. So a lot of time is much different from the ideal. If you look at the ideal one, when we talk about the process itself, it looks so nice. Well, so this is what happened. So if you look at the left-hand beagle, this is the low wastewater. So just now, student may have some think about what is this chemical process? Why are we adding chemical? So if you look at the beagle on the left here, on the right here, you can see after we adjust chemical and we make sure the right dosage is there, the solid and liquid start to separate. So if we look at the supernatant of the water, it will be very cold. The water become very clear. All right, so this is what real life look like instead of the ideal. So when we talk about quality of the wastewater, we must understand what is the purpose of the water treatment. When we talk about IoT, we want to monitor, we want to make sure that all the monitoring is up to the crowd. But we must set a standard for this system. So here I have put in a very basic part here. If you look at the beagle, EQ means that this is the equalization point of the wastewater, meaning this is the first stage of the wastewater. A lot of people will end on standard B. If you look at the chart, we have standard B. This one is the local standard, which is the standard set by Malaysia government, standard B. So if you look at it, this picture, the clarified water is not that clean. And some customer, the factory is located at water uptake area, meaning that they are discharged downstream. There's water treatment plant taking the water for consumption purpose. One of the example is that some of the water plant, when heavy rain, we have no water of consumption because some of the discharge from the water treatment plant is outstandard. So if your plant is located at standard A, then you have to fulfill standard A. Here, I do not mention too much about all the detail, but we just look at the appearance of the water. So we look at it, standard A, we need further filtration, sand filter. This is what happened. Next will be on advanced water treatment. Advanced water treatment is those customer, they understand that they already spend like thousands of ringgit. Can they recycle the wastewater? Can they recycle the wastewater? So they will add in UF. UF is the short form for ultrafiltration. And if you have high mineral or salt, you can add in this reverse osmosis to further purify this wastewater. So here we must understand that what is the purpose of your water treatment? What type of quality of water treatment that we are looking at? So quality is the thing that we must make sure that the purpose of the wastewater treatment plant. Now, I think we go for another, just now we mentioned about the quality. So once we know that quality of the water treatment plant or the purpose of the water treatment plant, as I mentioned, some customer, their objective is to make sure they comply to standard B. Standard B is the general discharge standard. So if you look at it, this is the general wastewater plant. So most of them, they will have inlet flow meter to ensure how much wastewater going into the wastewater treatment plant. They have pH controller to ensure that what is the raw wastewater pH. Next will be adjusted pH after the chemical adjustment, what sort of pH we are getting. And next, at the clarifier, as you can see from the beaker, if the water is clean, then the turbidity is low. So when we want to measure how clean, how effective our treatment is, we can install a turbidity analyzer to ensure that the chemical that we put in, the pH that we adjust, it will produce the result that we want. So turbidity low, meaning that the chemical treatment is effective. Next, it will go to the filter. Here we install a pressure gauge. A pressure gauge. This pressure gauge will measure that whether the filter need to recycle, time for it to what we call backwashing. Before it's being discharged, the government, Malaysia government, inquire all the treatment plants need to install an outlet flow meter. This is to ensure the inlet of the wastewater plant and outlet of the wastewater plant, the flow rate is about the same. We want to make sure no leakage is actually happen in the wastewater plant. Next, if you look at this side, this is the chemical portion. We know that a lot of time error mistake might happen. So when the chemical preparation, you have to make sure that it's all time there is chemical. So we put in this level sensor to ensure that the chemical storage is there. So altogether, if you look at it, we have 9 parameters to monitor. Student, bear in mind, this one is one of the sample of the water treatment plant. So we try to, this is the sample I take. So if you look at it, we sensor and monitoring tools. We have flow meter, we have ultrasonic, we have pH, we have turbidity, and we have pressure gauge, but all of them all together is 9 parameters. Okay. So after we have all this sensor and the monitoring tools, this is the time whereby we need to collect the data. We collect data by sending it into a recorder or chart recorder so that it can transfer to a PC to record and to process. This process is actually very similar to this Industrial 3.0. Whereas Industrial 3.0, we are talking about PC, personal computer, to process the data. Later, I will show some of the data, how it was being monitored and recorded. So if you look at it, from our wastewater treatment plant, we send all the data being collected and we transfer into our PC. This one is considered as Industrial 3.0. And next will be, after the data is being collected, we use gateway to send to the cloud. And once the data is being sent to the gateway, we will have most of the sensor is what they call Internet IoT, because Internet is actually mean that Internet of Things. So we managed to let all the sensor and our instrument to go to the internet to monitor further. Right, student, is there any question like to ask or want me to slow down, explain more? I think let me know. Otherwise, I think I will just go ahead to further discuss about our Industrial 4.0. So just now we mentioned about data collection. There's quite a number of ways you can collect your data. Here we are using a paperless recorder. So as you can see, all the sensor that we use in the industrial, normally they will have a standard, which is each of this sensor, they will give you an output. And this output, it can be in the millivolt output. It could be in 4 to 20 milliamp, or it could be other else. I beg your pardon. So all this data, it will be recorded somewhere so that we can transfer into PC. So this is the selection of what we do here. So say if you have quite a number of this data you want to collect, you can have few of this machine, the data logger, to keep all the data. And when we want to transfer to PC or anything, normally in industrial standard, we are using RS-485. It's the communication language that we communicate with sensor and machine. So to transfer the data, there's few methods that we can do. First is using hard wire connection to our PC. Secondly, you can use LoRa, long range radio wave. Long range radio wave, I think, is very famous here because it consumes very low energy. It consumes very low energy. Or if your site consists of Wi-Fi module, it can access to Wi-Fi. So our machine can connect to the Wi-Fi. And for some cases, if your wastewater treatment plant have no Wi-Fi, there's a lot of building blocking this radio wave. You can use another option, which is a cellular module. Cellular module is basically using Maxis this Cellcom to get the data, to transfer the data. This is some of the options that we can do to ensure that the data being transferred to cloud and to our PC. Next, this is the interface that we mentioned when we want to monitor all this data. As you can see, what we did here is when some of the data is outrange, here a typical example, pH, we know 7 is neutral. If it's too high, like 8.9 or more than that, so the indication is it will change to red color to alert those people who are doing the monitoring. And all the chart, the analysis from the computer, it will do the recording. Next, there's a number of interfaces when we talk about keeping the data, or what we call is a dashboard of the water treatment. For us to understand more and easier for us to digest all this data. So if you look at it, this is TrendView, whereby you can see it's fluctuating. So anything happen to the wastewater plant, say the incoming of the water, pH is not stable, so you will have this type of trend. This is a generated value. I don't think in any wastewater plant, the fluctuation is that big. Okay, this one, if you look at the bar view, you can see some of it is changing to red color and some of it is not. So some action can be taken. All right, now from data collection, we want to send it to the internet and make sure all the device is IoT, Internet of Things. So we must have a gateway. This is the part whereby all the data being collected and sent to the cloud. Okay, so the software and the industrial application is actually developed in Malaysia. What we do is we are using Telegram as the platform for us to monitor our data. This Telegram, there is the benefit of it is you can make sure the collaboration between colleagues, because in wastewater plant, You will not have one person in charge of everything. You must have a group of people. For instance, you have 4 operator, 1 competent person, your manager. So we're trying to group everyone into this group. And this is the part whereby we can monitor it from any way in the world, as long as you are actually linked into this app. Okay, so the collaboration will be very easy because everyone can view and everyone can see. So when you log in the system, this is the indication. This is some data about our internet gateway. So if you log in into the gateway, you can see what is the condition of the gateway, whether it's too hot, the battery is still operate properly. Because our gateway, there's some power backup. This one is just to ensure that the data won't just break down immediately. So we have about 24 hours of battery backup over any site. Next, there's quite a number of options. First of all, you can trace back your data. You can view the dashboard of your wastewater treatment, and you can view, if you want to download all the data about maybe few months ago or a summary of this month performance, you can download the data easily from this IoT. This one is one of the example how you can get all this big data, because all the data is being stored. And a lot of people ask me, we keep so much data, what are we going to do with the data? So certain things have to be done. I think the most simple one is we can let it plot some graph and analyze those data, because this one is the very clear indication somehow your production changes is a lot. The production changes from the wastewater plant is actually indicating there might be some leakage of product, because none of the production we want to waste a lot of chemical or there's some leakage of the product. So if there's a changes of the wastewater plant, meaning that the process or the manufacturing process, there is some problem. So it is a valid indication that certain improvement have to be done. So if you draw this graph, you will realize that what's happened in the production, maybe there's some changes of product, there's some leakage of certain chemical, or there's some human error that happened in the production. So that's what we can do. So you can send a direct command into our gateway. It will help you to generate what we call a graph here. A student, if you look at it, in this chat room, or what we call a monitoring IoT system, whereby all these people will being added into the group, it will give you a summary about what happened in the plant, and not just how to say, it not just give you a warning like alarming people that is failing. So if you look it back, you can generate the graph every month or every day. It will generate this thing. So you will how to say, you can analyze the data and you can find out more information about the system. So this is what happened. Let me see, we have half an hour left. Okay, so let's see what we are having. This is another the selection, product selection, because some of them, they want better interface of this monitoring. You can have this round type, you can have flat type of the chart. This one's some of the summary of our IoT system. Okay, this is how it look like for our dashboard. Obviously, this one is taken. This one is how to say, this this is the dashboard of the water treatment. So you can put in all this critical data. This one is real time. So when you log into the system, you go to the dashboard, you will see this data, and the data is normally blinking. You can set like every 10 seconds, the data is being renewed. So anyone is oversee or the boss want to see what happened in the wastewater plant, they just need to log in into it. Then you will know what is exactly happened at our plant. So as you can see, you can put in some comment and make sure you get the percentage of the water to some family. This is another view of the plant. Okay. The software that we developed so far, we can customize picture and we can customize a drawing into what we want. Say, for instance, your system doesn't look like this. You want to have a customized picture or customized flow diagram. We can customize to what you want. Next, about internet security. So just now, when we talk about IoT 4.0, we have to make sure the data is being secure. So anyone who is in this group, they will be able to view our system and our flowchart. And what they need to do is when they click on it, they are required to key in password so that all this data is secure. So once you log in, only you're able to access to our internet, what we call this dashboard of our water treatment. Okay, this one is some of the data which is underdeveloped. We understand that for water treatment, we must analyze the water. So this one is another way we analyze through this what they call season effect. Because sometimes when the weather is hot, we will have lack of water on we need to use more wastewater into recycle the wastewater to become part of the production water. But wastewater is the cost of the wastewater is high compared to river water and SAJ. So if you can get the meteorology data on the raining pattern, you can start to estimate when is the time you need to use your wastewater, become the feed water into your process. Okay, this one is, if you look at the history chart, the history chart is that we bought from the meteorology department. So we know that the dry season of Malaysia, here we are referring to about month of July and June, but it is somehow changing. So we can't really say that that particular month is really drought season. So if we can predict it, then we will know when is the time we can process our wastewater to the best of it so that we can recycle the wastewater. I think students may have some doubt. Why don't we just use all wastewater rather than sometimes we use wastewater, sometimes we don't use wastewater to process until RO. The reason is if we use river water, the treatment cost we are looking at is about 10 cents to 20 cents. While if you process the wastewater to become recyclable, the cost is about 2 ringgit per meter cube. The cost is much, much higher. But when you have no choice, drought season, you have no water, then you have to use your wastewater. This one is when you have drought season. And here there's a parameter which is TDS. TDS is the total dissolved solid. So when you have drought season, seawater comes, somehow it will start to contaminate the inland water. So I doesn't know anyone have experience whereby if you live near the quarry, the quayside, you will see somehow there's some this jellyfish start to swim into river because the salt water start to go inland. And all this salt water will have impact on river water treatment. So if you have a lot of this type of thing, then it is time for them to stop the river water treatment and start to push for 100% of recycled wastewater. And somehow, our government, what we call SAJ water, when it's drought season, the supply of the water will have issue as well. This is whereby the time for us to process more wastewater recycling. Okay, so this is how you can mix wastewater with SAJ, and by understanding what is the chemistry or what is the content of the TDS inside. So I think my presentation will be quite short.
Okay, thank you, Mr. Lim. So thank you for the fruitful sharing. So now I would like to open for the Q&A session. Any question from the audience? Anyone? There are about 131 students here, participant. I think they should have a question, at least one question. Dr. Rafida, unmute please. We cannot hear your voice. Still cannot hear you. Okay, we cannot hear you, Dr. Rafida. Probably you can ask your question in the chat box. Okay, Mr. Lim, probably before we wait for the question from the audience, I think I would like to ask one question for you. So, based on your presentation, so you are integrating coagulation for the dye wastewater, right? So one of the step in coagulation is to operate at optimum condition. My question is, did you carry out jar test regularly to obtain the optimum condition? Because just now you mentioned that sometimes the characteristic of the wastewater will be varies according to the climate condition as well as the operation of the factory. So did you carry out the jar test regularly, or you just based on one jar test?
Jar test is when we are doing the initial test. We did run certain jar tests to estimate the cost of the treatment. So if you look at it, for textile industry, it's quite interesting because their output or what we call their product is really depends on season. Even though Malaysia, we do not have season effect like spring, summer, autumn, and winter. But this textile industry, Batu Pahat, they sell a lot of garment to Europe and American and some of the season country. So it is we are sure that on August, September, they start to manufacture or they start to dye winter season clothing. Winter season clothing mostly is dark color. So you need more chemical or you need more of this coagulant to remove this color. So basically, this is the time whereby you need to have more chemical. So the jar test will be done to ensure that the dosage of the chemical is being calculated. Another one, it will be on summertime. Summertime, a lot of people like to wear those clothing which is cotton and which is how to say, more comfortable because summer is more hot. I think Malaysia, a lot of people, they like to wear cotton type of clothing and this thing. So cotton is it's organic. It's not like what we call a TC material to make clothing. So all this cotton, they consist of high organic. So the chemical dosage will be different as well. So I will not say every day we do the treatment, the jar test, but it depends on every month or weeks that we conduct jar test.
Mhm. So the factory will inform you, yeah, if they would like to change the manufacturing for the different season, they will inform you, is it?
No. They know how to do the test.
Oh,
They
okay.
know how to do the test. We
Mm.
show them how to do the test. And I think if student is interested, maybe we can have a session about how to do the test for jar test as well. I think it took about few hours for us to show them how to calculate the dosage and how to do this scale up of the chemical dosage into the actual application.
Mm. Okay, thank you, Mr. Lim. I think I have one more question that probably you can share with the rest of students. As you know that most of the audience is the civil engineering student. So since we are moving forwards, we are now in the IR 4.0 and then we will have IR 5.0, I think, in future. So how far it is very important if we as a civil engineer, as for the student, a civil engineer student, to know at least a basic knowledge as for the IoT, we should know at least about electrical engineering as well as the software engineering, right?
Yep.
So how to what extent that at least the civil engineering students should at least have the basic knowledge on this other type of knowledge in terms of electrical or computer science or software engineering for them to understand, because in automation,
Yep.
as well as the using sensor, right?
I think for civil engineering and this wastewater treatment is part of civil engineering courses, right?
Yeah.
Okay. So I think for IoT and all this I think for IoT, for Industrial 4.0, first thing we must need to know is what sort of quality and parameter that we need to monitor.
Mm-hmm.
I think just now when I show the purpose of the water treatment, we mentioned about there's few purpose. Firstly is to comply government standard. That is the basic of any water treatment. So just now I also share another example that some customer, they want to recycle wastewater. They recycle wastewater maybe due to cost, maybe due to geography condition, or it may due to this government water supply. So this is the thing that they need to understand. So one, they know that it can generate certain economy benefit. I think a lot of people were willing to do so. Willing to do so. So on the parameter, they can refer to the law book to get what they want. And for the recycle, we need to know the process of the factory or what is the purpose. Because if you look at textile, they want to recycle the water. Firstly, the water have to be 100% clean. There's no color, no dye stuff is remaining because the color is changing. Maybe this process, they are dyeing black color. Next process, they will be dyeing on red color. So if there's a remaining color in the wastewater, it become a big impact. So some customer, they want to recycle the wastewater, or they want to further process the wastewater for boiler purposes. Boiler purposes is whereby we need highly pure water. Easily we are looking at conductivity of the feed water to the boiler below 60 microsiemens or ppm. So you need to fulfill those requirements by adding RO and adding those things into it.
Okay, thank you, Mr. Lim. So I would like to read one question from Dr. Rafida. So Dr. Rafida said, "Thank you, Mr. Lim. At the moment, how many percent of recycling wastewater industry based on your experience?"
Okay, the recycle of the wastewater is I'll take few examples. For textile, I think we are looking at 20 to 30% of the wastewater being recycled. So only 20 to 30%. For in-waste, we are looking at 70 to 90%. 70 to 90%. In-waste is what we refer to when you are printing something on your paper. Those ink which is remaining. The reason why it can recycle so much is water that you need to mix with ink. There's not much requirement. You can have very pure, poor quality. You can mix with those ink. Then you can print the ink on the carton box again. And for food industry, I think it's about 10 to 20%. 10 to 20% of recycling, or not really recycling, they use for other purpose. Because we know that for food industry, for instance, I think at Batu Pahat, we have Munchie, we have 7 Day, right? Their wastewater.
Meow Meow, we have Meow Meow factory.
Meow Meow as well. So what they did is they take the final discharge, they go to water their flower, they make sure the plant, the greenery of the factory, because there's still some nutrient left behind.
Yeah.
You can't use it for production because we have to make sure that
food process.
they comply to HACCP and that sort of thing. So I would say it depends on type of industry and the cost of it, the operation cost for this wastewater plant.
So hopefully, Dr. Rafida, your question has been answered. Yeah. Okay. I think some of the students would like to ask for you if it's possible for you to share your slide, your PDF slide copy, for them to have it. Is it okay?
Yes, for sure. For sure.
Later you WhatsApp me, forward it to my WhatsApp. Yeah, Mr. Lee.
Thank you. Thank you. Can be done.
I think my last question, I think, before we end up our section is as you had been involved for 23 years for the wastewater industrial. So there are various type of client coming to you to design their wastewater treatment plant. What are the main that they always consider? I believe it is about budget, right? That is the main thing, right? When they would like to receive any design for you, for sure it will be the budget thing, right? Or is there any other factors that they consider?
I think most of it is the operation cost and the building cost. Operation and the building cost. Let me share with you some of the industrial wastewater issue. We have quite a number of customers. They built their wastewater plant by other contractor because they were told that the system is very low cost. And they take this advantage to buy some of the treatment method which is not matured enough, like those technology which is not matured. So about 6 months, they realized that they will never comply. So at the end, they have to look back to us and ask us for a better solution. Yeah. So I wouldn't think it is 100% about the cost. But we also need to make sure whether do you have success story. So I think for people, they ask me, do you have success story on food industry? You must have an idea what is the basic treatment method. I give you an example for those biscuit making factory. Biscuit is actually consists of very high COD, BOD, and oil. We are looking easily about 10 to 20,000 ppm of COD. So using normal secondary treatment to break down the COD and BOD, you will have difficulty because it's too high. So what we did is we have physical chemical treatment and this biological treatment, right? Beside that, you must have something what we known as anox. Which is partially aerobic and partially anaerobic. The reason why is it will break down some of the oil. And once it breaks down, we're using the power of anaerobic bacteria. Then only it can comply to standard B easily. So I make this mistake when I first built wastewater treatment plant because thought that it can comply, but it doesn't end up that way.
Yeah, yeah.
It's actually failing. The discharge is still too high. So you have to add in this anaerobic bacteria to break down. I think any civil student, when you look at the design criteria, the first thing it tell you is that physical chemical treatment, we are looking at 30 to maybe 60% of removal for physical chemical treatment. For aeration, we have maybe 70 to 80. But there's another rule of thumb is when your COD, BOD is very high, we will prefer anaerobic process. So but they will suggest that when you have maybe 50,000, 30,000, you go for anaerobic, right? So if you have something that in between, then you can go for what we call ANOX system, which is half of it.
Yeah, I think that is the main challenge because you are dealing with wastewater that have various characteristics for different industry. You will deal with different type of wastewater. So for sure, we won't have one type of treatment system that able to suit everything, every type of wastewater. That is the challenge, right? Okay. Okay, thank you. I think
Let me
that's
share another story. Let me
yeah,
share
sure,
another
sure.
story.
Okay.
Right. We have a case that whenever we want to design a wastewater treatment plant, so customer was so worried that it will be very expensive. So when we go to the plant and we start to collect their wastewater and we do what we call industrial wastewater characteristic study for 3 days. That is the basic requirement from DOE. And because they also scared that the cost of the treatment plant is very expensive. So they tend to run the less polluted process to generate those wastewater as the pioneer or as a case study for us. So it end up when they are running the actual actual process, and the characteristic study is 3 to 4 times different. Even though when we design wastewater plant, we add in a safety engineering factor by 30%, it can't cope. It can't cope. So I will tell my customer or those factory that you must do this when we collect the wastewater, you must send us the worst scenario for us.
Yes.
Don't be shy, don't hide anything. Otherwise, when the plant is done and you realize that you cannot comply, that is the time whereby you need to pay twice.
Yes.
Because we can't do much because that's the data you provide to us.
Then you charge more lah, Mr. Lim.
No.
For the second design.
You must give us the worst scenario lah. Say for textile, you must maybe send us the winter type of waste. Don't give us those summer and very light waste because at summer winter people tend to wear a light clothing, which is mean that the color is very light. So the chemical treatment COD is also very low. At the end, we will make a mistake. It doesn't reflect to the actual situation.
Yeah, that is something that the students should know when if you are involved with the wastewater engineering industry. When you want to design the wastewater treatment plant, first of all, you need to do the characterization of the wastewater itself first, and during the low pollutant concentration as well as a high pollutant concentration, so that you get that you're able to design according to the worst scenario of your client wastewater.
Yeah, if the engineering factor we put 2 times, 3 times, the plant is very expensive. If we don't do that, we worry that customer or those factory, they do not give us the actual data.
Yes. I think that's all. Mr. Lim, do you have anything more to say before we end our session, or any advice for the student?
Not really.
Just study hard, right? Study hard. That's all, right?
Okay.
Okay. Okay. Thank you so much, Mr. Lim, for the fruitful
Thank you.
sharing. We obtained a lot of knowledge, especially on the wastewater treatment engineering, as we know that most of the audience is civil engineering students. So basically, they will know that as a civil engineer, you only involved with the construction process, but as you should also know, it's also part of civil engineering task, actually. Yeah. Thank you, Mr. Lim. So with that, we end our session. Hopefully, we're able to have another sharing session later on, maybe next year with the different student.
Okay. Okay. Thanks for
Okay, thank you
inviting
very
me,
much.
and I
Okay.
wish to have this session every year. Mm,
Yeah, sure.
okay.
Sure, sure.
Okay.
Thank
Okay.
you, Mr. Lim. Thank
Okay.
you.
Thank you.
Okay. All right. Okay, for the student, I will display the attendance links. Please fill in the attendance link before you
Mm,
left the Zoom meeting. Thank you. Thank you
okay.
so much, everyone.
Thank you. Bye.
Bye.